Alright, so this video is for the ambiguous case for the law of sines. Alright, so now as you can see here we have almost a triangle. I kind of left A not touching the base of the triangle for a few reasons. Alright, number one, here we have two sides and an angle. Now if you notice from before, we had a little different information. We either had angle side. We either had an angle, a side at an angle. Or say two angles and then a side. But we've never just had two sides and one angle before. Now this is important because now that we have two sides and this angle here is fixed, we might not always be able to make a triangle with the given information. All right. So there's a couple things you have to look at here. First of all, it'll be easiest to explain it by drawing in a right triangle. All right. Now remember, law of sines is when you don't have a right triangle. But for this explanation, I'm going to make a right triangle out of this using this top vertex A and side B. So now this is the height of this right triangle. All right. So, and of course, here's our fixed angle. Now, to find the height, we know that it's going to be the sine of angle A equals the height divided by B. All right, because this is opposite and hypotenuse. So if we want to find out what just h is, we multiply both sides by b. So b times the sine of angle A is going to equal our height. Now, why is that important? Well, it's important for a few reasons. Number one, all right, if this side here is less than the height of the triangle, all right, so say this is 10 and say the height here is 15, all right? If A is less than the height, then this is going to give you no solution, all right? No triangles are going to be able to be made because if side A here is shorter than the height, when you rotate this back and forth, it's never actually going to go down and touch the base of the triangle down here, all right? So if A is less than H, no triangle. Number two, if A equals H, all right? If you find H and H happens to say H is 15 and A is also 15, then there you go. You have a right triangle. So you have one solution there. All right, one solution. Now, there's another case where you have one solution as well. If side A here is greater than side B, all right, so A is bigger than B. So let's say A is 15. We can forget about what H is for the moment. So A is 15, B is 10. You're going to be able to make one triangle. All right, you're going to be able to make one triangle. Now, case number 3, or 4 really, because there's 2 for case 2. All right, if A is less than side B, but greater than the height of the triangle, you are actually going to be able to make 2 triangles. So you're going to have 2 solutions. All right, here's why. Let me see if I can get this to work. All right, so A is physically shorter than B, all right, like we have here. Now, if we were to pivot this, let's see how well I can do this. If we were to pivot this, all right, it would make a nice little arc down here. And this side A would also hit here, making not only this triangle, okay, but you could also make this triangle here as well. All right, so if A is less than B but greater than H, you will have 2 triangles. All right, make sure you write this down. You're going to need this. Number 1, A is greater than H. A is less than H, sorry, no solution. Number 2, if A equals H or A is greater than B, you're going to have one solution. If A is between B and H, then you're going to have 2 solutions. All right. So let's look at a problem here. Say A is 40. Oops, I'm supposed to say 47. Say A is 47 degrees, and say angle B here is 62, and side A is 70. All right. Well, if you notice, A is greater than B. Okay, that's not negative 70. I just accidentally hit the board. All right. So 70 is greater than 62. So this means we have one solution. All right. A is greater than B. So we have one solution. So now you just do what we did yesterday to figure out what the rest of the sides are. So to start out, let's go ahead and find angle B. Well, we know that 70 over the sine of 47 degrees is going to equal 62 over the sine of B. Okay. Now, since our variable's down here in the bottom, we're going to end up cross multiplying. So 70 times the sine of B equals 62 times the sine of 47 degrees. All right, let's get rid of this 70, so divide it off. So the sine of B equals 62 times the sine of 47 degrees, all divided by 70. All right, so the sine of B, just grab your calculator, type it in. The sine of B is going to equal 0.648. And of course now, to find the angle, we're going to take the inverse sine of the 0.648. That's going to give us B. So B equals 40.4. All right, B equals 40.4. Now that we have two of the angles, it's real easy to find the third one. You just do 180 minus the sum of these two. So angle C is 92.6 degrees. Now we want to find length C. Okay, we want to find the side of C. So again, always go back to some given information. Because say you did something wrong here and you got one of these numbers wrong. So if you use the 40.4 plus the fact that it's a rounded number, but stay down here, we accidentally wrote 6.4, I don't know, 5, or maybe when we typed it in, we accidentally put 0.948. Of course, it's going to throw this angle off here a little bit. So I would always suggest going back to your original information. All right. So to find letter C, we are going to do 70 over the sine of 47 degrees equals C over the sine of 92.6 degrees. All right. So C equals, multiply both sides by the sine of 92.6 since our variable is in the top. So we're going to have 70 times the sine of 92.6 degrees divided by the sine of 47 degrees. Punch that into your calculator and C will come out to 95.6 units. Okay. So that equals 95.6 units. Now let's look at our triangle and make sure it makes sense. All right. So if we look, the largest angle is opposite the largest side, and the smallest angle is opposite the smallest side. So it makes sense. So therefore, we are done with this problem. All right. So remember, if if A is greater than B, okay, if A is greater than B, then you only have one solution. We didn't need to find a height in here because we knew since A was greater than B that we only had one solution, so we didn't have to worry about finding the height. All right. Let's look at another problem here. Say B was 61, A was 50, and angle A was 39 degrees. Now for this one, A is less than B, okay? But now what we have to do is, this is a problem where we have to find the height of the triangle. So we need to find h. Alright, so we have our right angle, and we know this is h. So we know that the sine of 39 degrees equals h over 61. Multiply both sides by 61. Punch this into your calculator. 61 times the sine of 39 degrees equals h. So we know that h equals 38.4 units. Now, since A is between B and H, that tells us that we're going to have two solutions. We're going to have two triangles. All right. One of our triangles is going to look like this, where B is an acute angle, and the other one is going to look like this, where B is going to be an obtuse angle. Now, I'll show you in a minute how to get this angle B. Let's first go ahead and get this angle B right here. So you're going to do it the same way we've been doing it. 50 over the sine of 39 degrees equals 61 over the sine of B. Since our variable's in the bottom, we're going to cross multiply. So 50 times the sine of B equals 61 times the sine of 39 degrees. Divide both sides by 50. So the sine of B equals 61 times the sine of 39 degrees divided by 50. Type this into your calculator, and we get the sine of B equal to 0.768. So take the inverse sine of 0.768. That equals B, which equals 50.2 degrees. Oops. So B here is 50.2 degrees. All right. Now, in order to find this angle B, what you're going to do is you're going to take 180. All right, 180. What can I write this? Let me write down here. And subtract the 50.2 that we just got. All right, that'll give you 129.8. This 129.8, it's this angle B. All right, because these two angles are supplementary. This angle B here and this angle B here, they're supplementary. So since this one's 50.2, this one has to be 129.8. And of course, we know this is 39 degrees. And we know this B here is 61, and this A here is 50. All right, we don't have to worry about finding the height of this triangle because we know it's the same as this one. All right, but before we move on to get any more information on this triangle, let's finish this one. Okay, let's find angle C and side C. Well, again, we have two of the measures here. All right, we know A is 39. We know B is 50.2, so simply 180 minus the sum of those two gives us angle C as 90.8 degrees. So as you can see, this one is almost a right triangle. It's less than 1 degree away from being a right triangle. So now let's just find side C like we found the rest of them. Remember, always go back to using your given information. All right, always use your given information as much as possible. So again, 50 over the sine of 39 degrees equals C over the sine of 90.8 degrees. So C equals 50 times the sine of 90.8 degrees divided by the sine of 39 degrees. Punch all that into your calculator and you will get 96.9. So this C is equal to 96.9 units long. Again, check to make sure it makes sense. Largest side, largest angle. Smallest side, smallest angle. So it makes sense. All right, it makes sense. Now let's go to this guy. We're going to work him out the same exact way. All right, we already found our B. All we have to do is find our C in this case. And this is actually going to be the last problem we're going to do for this video. So remember, always go back to the given information. So let's do 50 over the sine of 39 equals C over, oh wait, we didn't find this angle. Well, we find it just like we found this C. You add these two together, subtract from 180, and this C is 11.2 degrees. So now this is going to be divided by the sine of 11.2 degrees. Multiply both sides by the sine of 11.2, and you get C is equal to 50 times the sine of 11.2 divided by the sine of 39 degrees. Punch all that into your calculator, and you get this C as 18.8 units. 18.8. So again, double check, make sure it makes sense. Smallest angle, smallest side. Largest angle, largest side. They both make sense. All right. So make sure you have that chart copied down of those little 3-4 cases I gave you at the beginning. Because remember, you can either have, with the ambiguous case, when you're given two sides and one angle in this fashion, okay? You're given this side, and a non-included angle, okay? So two sides and a non-included angle. You can either have 0 triangles, 1 triangle, or 2 triangles, all right? And of course, the way to figure that out is by this chart right here. If A is less than H, no solution because it'll just hang up there and swing. It'll never hit the bottom. If A equals H, you have one triangle and it's actually a right triangle. If A is greater than B, you only have one triangle as well. But if A is between H and B, you will have two triangles as in our last example. All right. So this has been your ambiguous case. Make sure you understand this for tomorrow. See you tomorrow.